So our next formulas we're going to talk about are volume and surface area. So volume is the space taken up inside of the shape. So now we're going three-dimensional. And when we go three-dimensional, we're dealing with cubes. So I like these visuals so that you could see how we're counting how the cubes fill up space. So right here we have a rectangular prism. And with that, we're going to have the side lengths of the bottom, so maybe a width and length. In fact, let's go ahead and write that in. Let's call 5 inches the width and 7 inches the length. And then we're also going to have a height. And for these rectangular prisms, what you could do is think about taking the area of the bottom of the shape. So like to find the area of this bottom rectangle, we would just take 7 times 5, but then to fill up the space that's taken up as we go up, we then multiply by the height. So we have 3 pieces multiplying here. So in this case, it would be width times length times height. So we would go 7 times 5 times 11. And actually, let me rewrite that so that we have our units in there, because then we can see how the units are changing. So we have 7 inches times 5 inches times 11 inches. So numerically, we're just taking 7 times 5 times 11, which is 385. And then our units are now going to be cubed because we're multiplying it to itself 3 times. So we're going to have cubic inches here, as we can see by each of those tiny cubes that take up the space. Now, as we change the shape of our prism, meaning changing the shape of the base. So with this one, our base was the rectangle. Now our base is a triangle, but the routine's going to be the same. We think about taking kind of just the area of the base, and then to fill up the box, we need to then multiply by the height. So in this case, we're thinking about the area of the base, which is 1/2 times base times height, where that 7.5, that would be our base, and then 8 inches would be the height. Oh, this terminology isn't great for this scenario, but just in terms of the triangle, base and height, but then we have the height of the box as well. So what we're going to do is, how do I want to rewrite this? Let's call this A, B, and C. So we would take 1/2 the base of the triangle, which is A, and then multiply it by the height of the triangle, which is B, but then multiply it by the height of the overall prism, which would be C. So to calculate our volume here, we would go 1/2 times the 7.5 times 8 times 16. But it starts with an area formula, and then it's a matter of multiplying by the height of the prism. So let's see, for that one, just to finish it up, we'll have 1/2 times 7.5 times 8 times 16, which is 480. 480, and then again, our units are inches, and that'll be cubed. So that's the general idea of volume, and then surface area is the area of each of the sides. So with our rectangular prism, what we would have are, let's see, we have the bottom, so we have 1, the top 2, and then the sides 3, 4, 5, 6 sides. And each of them are rectangles, so it would just be a matter of getting each of the areas along the outsides using our side lengths and adding them up. This one's a little trickier, but not too bad. Let's see, we'd have these 2 triangles, so we'd add up those areas, and then we'd have 3 rectangles. We have this rectangle over here, and this big rectangle along the other side. And what we would do is we would just be using this height as well as the side lengths of the triangle to get those areas. Now with this one, they didn't give us that side length along the outside. However, it looks like the cube is fitting pretty nicely like a right angle, so we could use some Pythagorean theorem to find that out if we needed to. Okay, so some general formulas here. So when we're working with cubes, which is just made up of a bunch of squares, our volume is going to be coming from taking that side length cubed. So we're taking A times A times A. So let's say we have a cube that is 2 inches on each side. So for the volume, I would take 2 cubed, which is 8. And then our units will be cubed there. And then for surface area, it's going to be made up of 6 perfect squares. So we would be taking 6 times 2 squared. So 6 times 4 is 24. And then surface area is an area, so our units are going to be squared. So volume is cubed, surface area is squared, just like how area is squared. Okay, if we change this into a rectangle, so a rectangular prism, like we talked about up above there, we'll be taking length times width times height for volume. So let's say we have 2 centimeters, 5 centimeters, and 3 centimeters. So if I wanted to find the volume, I'm multiplying 2 times 5 times 3, which is 30, and then we would have centimeters cubed. And then for surface area, we have a formula over here, but you could also just kind of see going around the outside and adding up the areas of the rectangles, where we're going to have 2 of each rectangle. So we're going to have 2 of these 2x3s. We're going to have 2 of these 2x5s. And the only one I'm missing is the 3x5. So 2 of those 3x5s. So let's see what we have here. 6 times 2 is 12, plus 2 times 10 is 20, plus 2 times 15 is 30, 50, 62, and then units squared. All right, let's take a look at some more shapes. When we have a cylinder, what we'll be doing for volume is taking the area of the circle and then multiplying by the height, again, to fill up that space with these cubes. So volume is coming from pi r squared and then multiplying by the height. And then for surface area, which is missing here, but this can be kind of good to build ourselves, what we're going to have are 2 circles. So 2 of these pi r squareds. But then what we also have is this kind of wrapped around surface area. But what you could think of is, imagine you have a hollow can and then you take off the top, take off the bottom. Just imagine you cut it open and lay it flat. If you cut open the can and lay it flat, sorry, it's going to make a rectangle. And the rectangle is going to have a side length with the height. That's what the height is coming from, this piece right here. And then the length of the rectangle is coming from the side that would have been going along the outside of the circle. So with that, it would be coming from the circumference of the circle, which circumference comes from 2 pi r. So we're going to have, for surface area, is 2 of the circles, and then plus that rectangle, which uses the circumference, 2 pi r, times the height. Okay, so let's say we have a cylinder with a radius of, let's just keep doing 2 meters, and let's use a height of 5 meters. So if I want the volume, I take the area of the circle, so pi r squared, but then multiply it by the height. So this is going to be 20 times pi, or we could plug that into a calculator to get a decimal, but let's go ahead and leave it like that. So that would be meters and then cubed. For surface area, we're going to have 2 of the circles, so 2 times pi r squared, plus circumference, 2 times pi times r, and then times the height to make it the area of a rectangle, which is 5. So this surface area is going to come from 8 pi plus 10 times 2, 20 pi. So this surface area is going to be 28 pi and then meters squared. Okay, last formula here is dealing with the sphere. All you need is the radius, and our volume is going to be 4/3 pi r cubed, and our surface area is going to come from 4 pi r squared. Okay, so we have a sphere here. Let's say we have a radius of 2 inches. If I want to find the volume, I'm taking 4/3 times pi times that radius cubed. So let's see, that's going to be 8 times 4 is 32 thirds pi inches cubed. And then for surface area, we're going to take 4 times pi times r squared, which is going to be 4 times 4, which is 16 pi and then inches squared. Okay, so there's all of our formulas and some examples, but now let's go to an application and try it all together. So we have a florist fits a cylindrical piece of foam into a conical vase. So an image over here, in green here is our cylinder, and then the conical vase is this big cone right here. So we have 10 inches high for the cone and 8 inches across, so it's giving us the diameter at the base of the cone. And if the radius of the foam cylinder is 2.5 inches, that's what they're giving us here with the 2.5 inches, how tall should it be just to reach the top of the vase? And let's go ahead and kind of dissect this apart. In fact, imagine, say I cut right through the middle of this vase and cylinder and think about what that would look like. What we would end up having is just this big triangle. And then fitting that cylinder inside, what we would have is this kind of line across. It's also going downward, but for this image, let's just think of it like this. So what we have in terms of distances is we have this height of 10 inches. What we have is this half distance of 2.5, which, let's go ahead and just say that's a total distance of 5 there, and this total distance of 8. And what we want to find, the height of the cylinder is going to come from this distance right here. So what we could do is at the same time use this missing distance right here. And what you should start seeing are similar triangles here. So even though we're working three-dimensionally in terms of kind of visualizing a cylinder and a cone, we could think of this separated from it. So with this, what we're going to have is, let's go ahead and call this x, which means this missing piece would be 10 minus x. What we can do is have our two triangles. We have our big triangle and little triangle. And what we just said is this has a height of 10 along a base of 8. This has a height of 10 minus x and a base of 5. Let's go ahead and take our ratios. So 8 to 5 is equal to 10 to 10 minus x. And let's cross multiply so that we'll have 8 times 10 minus x equals 10 times 5 for 50. So let's see, we'll have 80 minus 8x equals 50. Take away 80 for a negative 30. Divide by negative 8. And let's just get a decimal out here. So 30 divided by 8 for 3.75. So 3.75 is going to be our distance right there. So we set it up and could use similar triangles to solve, and we wanted to know how tall should it be to reach the top of the vase, which it is the cylinder. So if we go back to our three-dimensional image here, so what we did is we kind of focused on this triangle here, but in doing that, we solved for this height right here, which we found was 3.75. Now, just for the sake of practicing what we learned, let's say we wanted to find out some information about that foam cylinder. Let's say we wanted to find the volume of the cylinder. So for volume, we would take pi r squared, so pi times 2.5 squared, and then we would multiply it by the height that we just found. So you didn't ask for this, but just for the sake of practicing what we just learned with volume and surface area, we're going to take pi times 2.5 squared times 3.75. So the volume of that foam cylinder would be 73.63, and we would have inches cubed. Let's see, we wanted to know the surface area of that foam cylinder. We would take 2 of the circles plus the circumference, 2 pi r, times that height. So surface area, we just plug all of that in. Let's go 2 times pi times 2.5 squared plus 2 times pi times 2.5 times 3.75. Okay, 98.17 inches squared, or square inches. Okay, so that was just kind of some bonus pieces at the end there so we could practice our formulas, but really that could have been solved without even volume or surface area. Even though it's a three-dimensional image, you can think of a cut of it to make it two-dimensional.